So thanks everybody for joining. This is my first time speaking directly to the San Francisco Java user group. I've met a lot of participants at various conferences, working throughout various Java enterprise circles, and then with most specifically a lot of open source that kind of overlaps a lot of that same type of work. I mean, obviously, there's a ton of Java-driven open source projects out there. And today we're going to talk about developer productivity engineering. We're going to talk specifically about how we can maintain build performance as our code bases get bigger and bigger. So there's a reason why I started talking a little bit about enterprise concern and Java enterprise here, because typically, this is the scenario that we see, kind of mushroom. I think a lot of us, if you work in Java, specifically Java enterprise professionally, you can probably relate to, starting with a small project that gets larger and larger. So we're going to talk today about, how we can make sure that in doing that, in adding on a lot of new features and functionalities and things like that, which will of course come with more code and dependencies, that we can make sure that the performance of our build stays fast as it can be, stays as optimal as it can be, so that we as developers are getting feedback as fast as possible and we can do our jobs well. So who am I? Why am I talking about this? So my name's Justin Reock. You might have seen some of my other talks at various other conferences. I've spoken before at like OSCON and All Things Open and ApacheCon and a lot of Linux Foundation events, mostly around, again, various bits of open source, and specifically open source that touches the enterprise. So you may have seen some talks that I've given on technologies like Kafka or Postgres, or more recently things like Kubernetes. So I've got a lot of experience working in various software roles, including a lot of JEE work. I am a free software evangelist, although I think these days it doesn't need a lot of evangelizing. I think if you tell most people, hey, you should use open source software, people are like, yeah, thanks, we know. So really, I'm going to talk a little bit more today about, I think, some specific bottlenecks to productivity that we face as developers. Feel free to reach out on LinkedIn. I mean, I really am not like a closed wall or anything like that. I love networking, connecting with people. I wish that we could be doing this with the real bridge behind us, in person, like we used to be able to do. I mean, it was my job all the time to be on the road speaking at these types of events. So, in lieu of that, I'm very happy to network over platforms like LinkedIn, or you can send me an email. You'll see my stuff at the end, or reach out to us through Gradle. We have our Gradle Slack also. So if you have any questions that, you're not able to ask or get answered today, please don't hesitate to reach out. It's very much my job at Gradle to, I think, face the industry and make sure that everyone understands what it is that we're trying to do with developer productivity engineering. Little housekeeping real quick. I'm going to do my best to keep my eye on the Q&A and the chat panels. Please just feel free to ask a question whenever you want to. If I can't get to it right then, I'll kind of wait and get to it at the next section and do my best to kind of, make sure that that I'm answering those as I can. All right. So to kind of kick things off, I like to set the stage with this quote, which is from Eric Pearson, who's the CIO of Intercontinental Hotels Group. So I'll need to update this. But it's effectively this quote. It says, "It's no longer the big beating the small, but the fast beating the slow." All right. You may have heard some version of this quote. It's very popular right now because I think, with the success of patterns like Agile and DevOps, we've learned that being able to release more frequently and do difficult things more frequently through automation makes us better development organizations and allows us ultimately to ship better software. So what are we going to talk about today? Some specific bottlenecks to productivity that we think are sort of antithetical to that last statement about the importance of speed. So here we have sort of a developer, going about their work, and maybe they're building, in this case, in a local context, but the same bottlenecks and principles are going to apply to building remotely or building through some sort of CI. And effectively they're just running into problems getting feedback about the work that they're doing. So if you can sort of imagine each of these little loops as bits of feedback that developers are hoping to get, sometimes it just takes too long to get the feedback. Sometimes you get feedback, but it's broken, right? It blew up and it's taking a long time to fix it. Other times there's situations that are being encountered by developers that just could have been prevented altogether. Had there been someone maintaining a bit of oversight over the common failures that are being seen throughout the enterprise. All right. So all of these things, all of these bottlenecks, when multiplied by engineering days per year and hundreds of developers on team, they can really lead to massive productivity sinks that I think in a lot of ways we've sort of gotten numb to, especially if, this is our job and this is what we're doing professionally. But I think it's really important that we don't lose sight of the fact that software development is a creative process. It was always a creative process, from the beginning times that we all as practitioners started working with code and kind of working with computers. And it is, although a creative process, still a scientific process too. It's about experimentation, and it's about, executing things and trying things and seeing what happens when you try a new code execution path or when you try to write a new bit of logic. And when we first started working with technology and working with code, it felt like this: when we could make something happen, when we would experiment, and when whatever it is we were hoping would happen did happen. It's very rewarding, right? And when we were dealing with some of this more experimental, hello world, learning type of code, for lack of a better term, feedback is usually very quick, right? These aren't sophisticated applications. They don't take a long time to build. You do a println hello world and you get hello world, right? But sit back and look at how much fun these kids are having and put yourself in their shoes and maybe reverse that and put them in your shoes as the enterprise developer who may be waiting minutes or, in extreme cases, hours for feedback about a build or a test distribution cycle or a test cycle. I just don't think you're going to see this level of enjoyment. I don't think any of us really do. I think that working in the enterprise has created a very unique set of challenges for us as developers. The irony is that as our projects and as our work becomes a little more successful and more widely used and more important throughout an enterprise, typical things start to happen to the code base. The code base grows, right? We're contributing new features. We have new people working on the code base. We're being asked to do more with it. The number of developers contributing to and working on the code itself goes up. The number of individual repositories where we're keeping source code might start to spread or fragment. With those new features and new code is going to come a host of new dependencies. And ultimately, we're just going to increase the overall diversity and complexity of the tech stack. These are all signs of success, but they are also things that, when not managed, can negatively impact the time at which we're able to get developers the feedback that they need to continue doing their work well. And so as a result, I think a lot of calendars start to look like this. We get up in the morning as developers, we're fresh, we're ready to go. We're going to make some stuff happen for the business. We start writing some code. We're happy about it. We wait for our local build to complete. It didn't work quite well. We're going to spend some time messing around with it, maybe debugging our build failures, seeing if we can figure out what happened. All right, well, we're going to go to lunch. Maybe we're a little restored after lunch. We're going to get back to coding. And hey, this time our local build worked, right? Our debugging was successful. We were able to figure out what the problem was. Now we're going to push it to CI. Oh, but now we have to wait for the CI build to complete and to get feedback from CI. And maybe something in the test cycle in CI didn't match up with the test cycle locally. And now we're dealing with a non-deterministic test that has to be investigated. So if you look at this overall schedule, very little time is spent coding and a lot more time is spent wrestling with some of these issues. And this isn't really a theoretical situation. This is one of many surveys that have been run, kind of on this subject. And just drawing attention to the rightmost column here, we don't need to look at all of these results, but percentage of respondents frustrated by daily tasks, 76% responded that they're frustrated because they're waiting for CI pipelines to run. Waiting for builds and tests outside of CI pipelines is 74%, right? So overwhelmingly, a lot of frustration just caused on waiting for feedback from the build infrastructure itself. And as a result, teams right now are working far from their true potential. And it's not just about cranking out code and cranking out features. It's about developer happiness. And developer productivity is a big part of developer happiness. And personally, I think living in a world that's about to become 65% digitally transformed in terms of our global GDP, if you believe the most recent survey to come out of IDC, saying by 2022, by the end of this year, 65% of the goods and services that we pay money for will be digital. I think that we owe a responsibility to the practitioners and developers who are building all of this infrastructure around us and really, lifting us all up, no matter kind of what discipline we're in. And we need to work hard and engineer solutions to make them happy, because in turn, that's going to make the world a better place. And right now, low developer productivity is just blocking business innovation. There's more that businesses could be doing. And this is not, a new call to action or a new story even. I think that, if you look at disciplines across engineering and across, creative disciplines, we have been thinking about ways since, the 70s, really, in terms of how we can eliminate friction, bottlenecks, and constraints from the systems that we work with, that we rely on, right? And so for any of you who are familiar with, more recently, the work of Gene Kim and work like the Phoenix Project and the Unicorn Project, or, if you trace some of those origins back to the theory of constraints and the goal, right? Nothing that we're talking about today is I would say a technique or a strategy that's necessarily new. I'd say it's evolved out of a series of successful practices in the elimination of friction, bottlenecks, and constraints from systems and the reduction of work in progress, which is exactly what we aim to do with developer productivity engineering. So let's talk about that. Let's introduce the subject now that we've sort of laid the groundwork a little bit. When we say developer productivity engineering is the next thing, we kind of mean this literally, right? And what I mean by that is that this is like the next set of bottlenecks to address after we've done, I think, a good job maturing DevOps strategies and things like that, right? And it's not to say that you have to wait on one. It's that the industry at large has, for the most part, solved a lot of the friction and problems that we've had doing deployments across multi-cloud. If you've adapted to 12-factor and you've been able to have some success with things like microservices running multi-cloud on Kubernetes, which is, everybody's trying to do that right now. I think even if your business hasn't put these practices in place yet, it's fair to say that it's a solved problem, right? We kind of know what to do. So the next set of bottlenecks to clear then are these ones that are being encountered in the development process itself. And these are, these bottlenecks are, waiting too long on build feedback, waiting too long on test feedback. Once you get that feedback, taking too long to diagnose or debug failures or collaborate with team members on those failures. And so these are bottlenecks that exist, but they're not necessarily in scope for things like DevOps, right? Because they're very much within the realm of developer experience, just from more of an engineering standpoint. To break that thought down a little bit more, what we're not talking about is developer productivity management, right? So let's kind of be clear about that too. When we say that we're engineering solutions for productivity, we're not doing this to measure, how much output a single developer is capable of producing in terms of lines of code or commits or changes to the code base. That's within the realm of developer productivity management, which is an important discipline and one that's, I think, kind of well understood. We're arguing that we can use engineering principles, that we can create engineered solutions to also augment developer productivity. So whereas developer productivity management might be focusing on people, we'd be focusing more on process and technology. So the build infrastructure, the CI pipeline, the speed of feedback cycles, the efficiency of our tests, and whether those tests are flaky, right? So just want to make sure that we understand that. When we look at DPE as a practice, we can kind of start with the outcomes that we're hoping for across the business, which in many ways is just addressing these pains and bottlenecks that we were mentioning before. So let's kind of start with the pain. Let's start with the point of bottleneck, and then let's talk about what we really want and then how we feel like we can get there, right? So idle and wait time, we've already talked about this as a bottleneck, waiting on feedback cycles. What do we want? We want faster feedback cycles, right? We want to give developers the ability to build as often as possible so that they can experiment as often as possible, right? We don't want them to feel like they need to cram a whole bunch of code in all at once because they know that just building and testing that those changes are going to take, a prohibitively long amount of time. Because we all know what happens when you release too many changes at once, right? So this is really all about giving developers small, granular time slices that they can do their work within. So idle wait time, we're going to fix that. How are we going to do it? Well, right now, through a pair of techniques, build caching, which is just what it sounds like. It's not dependency caching. We'll cover that in a second. But build caching, so caching steps or tasks, parts of the build, and then distribution of tests, so the ability to run stateless tests in parallel across multiple nodes. Great. Once we've been able to get our feedback faster, what happens if it's negative feedback, failure feedback? We have a problem in the industry now of inefficient troubleshooting. A lot of the troubleshooting that we see now in the industry is really just, oh gosh, okay, here's the console log output from my local build on my laptop. I don't know why it failed in CI. Let me send this to you. Here's all the cores on my laptop. Here's my Java heap memory settings, and here's the garbage collect. And just dumping all this stuff over in Slack or in a ticket or something like that over to build engineers in the hope that they can turn around and decipher all that and help to debug. So we can do better, we feel like. And for that, we recommend a technique called a build scan, which is effectively the ability to capture almost like an X-ray of the entire build process and really see everything that took place in context. So console log next to dependencies, next to failures, next to tests, all in the same place and all shareable, right? And we'll look at a demo of this. Flaky tests, non-deterministic tests, and other types of avoidable failures. If you're keeping track of builds across the organization, it's actually very easy to detect these things. If you're rolling up and aggregating data about test outcomes, it's not hard to figure out that tests are passing for one group of people with the same code, the same compiled code, and are failing for another group, right? And that would be called a non-deterministic test. We need to call these things out because, as we know, these are black holes to productivity. Very few metrics or KPI observability in the dev process. I want to make sure we're clear that that's what we're talking about right now. This is like really within the developer experience, kind of at their laptop and to the point at which they've pushed something to CI and they're waiting to get something back. This is experience that we just know isn't as well observed as it could be. I think because you don't see a lot of products that are really interested in taking these types of metrics from a developer's laptop directly. But this is where a lot of these pains kind of live, and they're often just kind of kept dark from the rest of the business. And then finally, with so much work being done in CI and so many remote builds being done, we're finding businesses are really getting concerned now about their cloud costs. As they, have more and more distributed developers who are capable of capable of running these builds remotely out in the cloud. That's not free, and hundreds of developers just kind of willy-nilly pushing builds out into the cloud and using up all that resource, that can add up very fast. So inefficient use of CI resources, we want to be able to have efficient use of that. And so we recommend profiling all of the build resources and the impact of the build system that's really had across the dev organization. Okay. To break the solutions down a little further, for a little bit more technically speaking, the build cache and test distribution, faster feedback cycles by caching individual tasks in a single build. All right. So not like, not even really like the Gradle up-to-date task status necessarily, because this can work with Maven as well and Maven goals, but really saying individual modular parts of the build that don't need to be repeated unless code has been modified that directly impact them, can be left alone. They can be pulled from cache as opposed to running again. And then, of course, executing tests in parallel across multiple elastically auto-scaling nodes, right? And we have great infrastructure for this now with Kubernetes, right? I mean, the underlying infrastructure for elastic scale and high availability and all the things that we might want with something like this, along with metrics and observability, the infrastructure is there for us. Build scans, again, X-ray build with context. I feel like we talked about that a little bit already. Failure analytics, we want to be able to see failure rates in history. All right. So it's not just, that one developer had one failure that a build engineer helped to diagnose. What if we looked at those failures historically and found out actually that 50 developers had been dealing with that same failure over the course of the last couple of weeks? Wouldn't it be better to try to address that failure as a whole, as opposed to just on a one-off basis with a single developer? And then wouldn't it be better to make sure that once those once those changes go out to actually address this problem, that you have the observability to say, okay, this actually fixed it, and the failure is no longer happening, or the test is now deterministic, or the test is now reliable? And the same is true for inefficiencies and outliers, I think, in build times themselves, right? I mean, we want to understand if suddenly tests are taking twice as long to execute as they used to, or builds are taking twice as long as they used to. And again, all of this that extends, locally or in the local or remote build also extends out to CI, right? And certainly out to cloud CI. Any questions at this point? I don't see much chatter or anything going on in the Q&A or the chat. Oh, got one right here. How do you propose to help developers find unreliable build infrastructure? Great question. We actually get this one in the talk a lot. So when we talk about two types of tests and the way that we tend to the way that we tend to think about these tests, we think about these as verifiable and non-verifiable tests. All right. What that means is that a test is either like programmed or logically built to assert some state in the code execution path. So to say, okay, if I run this method with this parameter, I expect to get either this type of Java class out of it, or this type of data out of it, or a string or an integer or whatever it is. Or if it's a string, it's supposed to be this value, or some regular expression match on this value, right? That's something where we can say, okay, we're actually able to verify that this test actually, passed or failed. Non-verifiable is something like a timeout, right, in the infrastructure that happens maybe when we're trying to hit, I don't know, an artifact repository like Sonatype or something like that. Or if we're trying to hit some external service, maybe we rely on a database or a messaging platform, like a JMS broker or something like that, or Kafka or something along those lines. And that infrastructure is flaky. Those tests will actually still get detected in our model and determined to be flaky tests because they ran in some cases and didn't run in others. But they can be in our model, they can be labeled as non-verifiable tests, which is really handy, because then you can say all of a sudden we've got a spike in non-verifiable tests in this build infrastructure. You can point right to an infrastructure problem and kind of skip problems that might have been problems with just normal code assertion. Yeah, so that's a really good question. We get that one a lot. Anything else before we move on? Okay, thanks. Oh, most of the time my build takes is downloading, build, test, and compile dependencies. If I'd run it in parallel, it would be doing this process for each part. Wouldn't it be longer? Well, the downloading of dependencies and actually pulling dependencies into the build is something that's kind of outside the scope of developer productivity engineering. And I only say that because it's something that's already addressed by DevOps and by 12 factor, in that you want to keep your own dependency repositories as close to the code base as possible. So the better solution here would be to, like, for instance, build out highly available or elastically scaling dependency repositories. So things like Artifactory, Nexus, whatever you're using, like, you'd want to improve that part of the infrastructure. So it is like, you're completely correct. This is part of the developer experience, and it's part of waiting for feedback, but it's also something that's already covered by 12 factor development principles, and something that's already covered by by DevOps in general. Yeah. So with the cloud local Artifactory. So, again, if one of the things that you can do is execute a build scan, and you'll be able to actually see, and I'll show you this when we do the demo of a Maven build scan, but you'll be able to see how much time was spent downloading dependencies versus other parts of the build. You'll be able to see, like, how much data was downloaded as part of the build from the Maven dependency repository, which is going to give you some really good metrics and really just, room for improvement, for measuring an improvement there. You'll find when you look at your entire build timeline that there's obviously going to be other areas that are possibly cacheable, especially if your application is really modular. Where you'll be able to find some performance improvements that don't have anything to do with downloading dependencies. But in general, if that is a big bottleneck for you, if downloading dependencies is a big bottleneck, then the best thing you can do there is try to improve the infrastructure of getting those dependencies into your build. Cloud local Artifactory is good, but then you still have to determine where your slowdowns are coming from. Maybe your storage could be faster. Maybe your network fabric could be faster. Right. You probably want to look at those. But the thing is that you could actually, again, take a build scan from this process and determine exactly how much of that time you have spent downloading dependencies, and where there's room for opportunity to make that more efficient. So I think it's our second demo where we look at the scan. So I'll show you where you can actually do that right now with any Maven build. It's part of the freely redistributable stuff. Does the Gradle Enterprise build scan detect if Gradle is downloaded? Yeah. So if that was, do you mean so if the Gradle wrapper actually had to spend some time going and downloading the Gradle build binary itself? Yeah, it does. It does. You'll actually see that as an individual Gradle task as part of the wrapper output. So when you go and browse all of the tasks, you'll see that as part of the. You'll see that as part of it. There's all kinds of interesting things you can do, actually, which we won't go into now. But if you want to reach out, I can actually talk to you about that. But there's all kinds of things that you can do in terms of wrapping other parts that are executed by any parts of the build script. We have people doing the opposite too. Like, we have folks who'll execute like Webpack tasks, for instance, and fire off like Node.js builds and React builds. In fact, our own UI team does this. And they'll wrap the Gradle build script in that, just so that data can be pulled into the build scan. Right. So it's pretty interesting what can be pulled into it. But yeah, in this case, if there was time that was spent doing that, you'll be able to see that too. All right. Lots of good questions. Thank you, everybody. Let's keep chugging away. So very fast feedback cycles are important, right? That's kind of principle number one of a lot of what we're talking about here. So faster builds improve the creative flow. There's a couple of things that I want to point out when we look at the math here. All right. So first of all, let's just set the context for our kind of hypothetical scenario. Team 1 has 6 team members, almost twice as many team members as team 2. The build time for team 1 is 4 minutes. The build time for team 2 is 1 minute. Team 2 is able to execute 850 local builds, whereas team 2, with almost half as many developers, is able to execute significantly more builds in this period of time because their build time is 1 minute. Now, here's the problem with this picture in my mind, and the thing that I want us to all maybe take a second to think about. If you ask anybody in the Java EE community, that's running a decently sized Java EE application with a decent amount of API endpoints or anything like that, if 4 minutes is really hurting them, they're gonna say no. No, of course not. 4 minutes is fine. That's like industry standard for these builds. 1 minute, sure, that's better. But 4 minutes is fine. Well, I think we need to start reframing the question a little bit. I think we need to start reframing it and saying, how fast can our builds be? And if we can make them faster, a lot faster, then what's the real fallout from that? And this picture is really what it is that this team with half as many developers is able to run more experiments, right? Going back to our little hypothesis from the beginning, that a build is an experiment between the developer and the computer. I want to try some code and see what happens, right? This team is able to run more experiments as a whole with less people because their build feedback happens faster. Okay, so the real point here is that I think a lot of us should maybe take a look at our 4 minute builds or 8 minute builds, even if they're feeling like they're kind of healthy, and really ask, could they be faster and what could that do? When we look at it and roll it up to a whole business, going from a team of 6 devs up to a team of 100 devs, it's very compelling savings in terms of overall cost if we're doing thousands of builds a week across lots of developers. When we start looking at comparative cost, even with taking off the top for a certain percentage of overhead and whatnot, we can save hundreds and thousands, even for larger dev teams, of engineering time a year just by improving the speed at which we get feedback about our builds. So if we can agree then that fast feedback cycles and feedback cycles that are as fast as they possibly can be is really kind of what we're talking about here, then we can look at one approach and say that build caching is a tool for very fast feedback cycles. Build caching was introduced to the Java world by Gradle back in 2017, right? So it's actually a relatively new approach. It's available for Maven and Gradle. And it can support both local and remote caching for distributed teams. In other words, you can take advantage of caching parts of your build, either tasks if you're using Gradle or goals if you're using Maven locally, or you can also share a cache with a remote developer team and a CI pipeline, which is really great. The caching is super accurate. We've done, I think, a really good job keeping it very stable and very accurate. The cache ID and the cache key is generated by the Gradle task and the Gradle task and the Gradle task path itself, and then a signature of the compiled class runtime as well. So it's just not possible that you're going to pull something from cache that you really should have rerun locally when you look at the way that the architecture's been set up. And the benefit here is that if you've got a build that takes a really long time and you're trying to build into a clean environment and someone's already run that build relatively recently in CI, the remote cache is going to be relatively up to date, and you're going to have the opportunity to pull a good amount of that build from remote cache and really be able to get started just kind of immediately. The Spring Framework project is a really good place if you want to kind of try this yourself. You can go and I don't know if the last time you tried to build Spring from scratch, but since they pulled in Gradle Enterprise, which I'll show you where their server is, you can go and build Spring Framework now in just a matter of minutes, or even if you've already got all the dependencies pulled, then it's just a matter of seconds. It's really fast now because you're able to pull a lot of the stuff through the Gradle wrapper from Spring's Gradle Enterprise server. So these build caches, I want to just make sure everyone understands, are complementary to dependency caches and not mutually exclusive, right? A dependency cache is like, we're talking more like an Artifactory, a Sonatype Nexus type of solution. These cache fully compiled binaries that you want to download as part of your build. But what we're actually talking about is accelerating the building of a single source repository, right? Or a single set of modules, or a single monorepo or whatever. And that one build will have tasks and goals and part of it that can be reused from previous builds. So what we really do is just take a look at all the inputs to our Gradle tasks or Maven goal executions. This could be code, right? Mostly it's talking about code. Inputs to Gradle tasks or Maven goal executions are kept track of, and outputs are left in the cache, are hit to the cache. When the inputs to any of these things, the task path or the Maven goal execution path hasn't changed, then we just pull the output from the cache as opposed to pulling the output from having to rerun the task or goal again. And like I mentioned before, this happens. This can be set up really efficiently with a remote server as well. So if you can kind of imagine here, we have a CI server. We have a couple of remote Maven users here who are hitting a remote cache. And this is literally the setup, except that we're not talking about Maven, we're talking about Gradle. But this is literally the setup for Spring that we just talked about. So you, the developer, can come and pull the source code. When you go to try to build it locally, the Gradle wrapper is already set up with the GE Spring IO address and everything to go and check the Gradle Enterprise remote cache and see if you can pull all those build tasks from there first. So this is a really great place to just kind of, validate, what we're talking about. But also, if you're working with Spring often, and if it used to drive you crazy that to set up, build Spring in a new environment took forever, it doesn't anymore because of this. Spring's not the only open source tool that's using this right now. If you go to Gradle.com and if you go to customers, you're going to see an OSS projects page, and you can see all the different free software projects that we're donating this code to right now. If you have an open source project, there are strategic projects that we're considering, kind of given the tool set to. So feel free to reach out. We obviously believe a ton in community open source. I mean, that's the roots of Gradle, and we want to give back to those communities as much as possible. But just to give you some other public results here, the Commons IO library also running Gradle Enterprise on cache, 1 minute 23 second build. Again, 1 minute and 23 second build doesn't seem bad until you realize that you can turn on caching and have a 4-second build instead. Right? Google Guava, 7 minute, 19 second build down to 1 minute. Spring Boot, talking about that earlier, 21 minutes down to 6. It's lower than that now. The Tom EE project, so the Apache Tomcat EE extensions project, which is totally separate from the Apache Tomcat project. It's actually, I think, still a single maintainer mostly working on that, but it's a great project. Down from an hour and 27 minute build to 20 minutes. And this is Tomcat with a ton of enterprise extensions built in. So this is Tomcat with also ActiveMQ for JMS, for an EJB solution, for I want to say a JGroup solution too that wasn't included. I mean, there's a number of JEE specs that aren't part of Tomcat that are included in Tom EE. And if you can imagine building all of those JSRs out, I mean, it's a big build. We already talked about this again. Wayne posted the results. Faster to click the link in the chat probably than to look at the QR code. But to give you an idea, I mean, taking without build caching, more than a 20-minute build, with out of the box, taking it down to a 3-minute build. But we have other optimizations such as test distribution that we've talked about that have been able to drive the build time down even further here. All right, that's a lot of talking. Let's take a look at a quick demo here. So in this demo, what we've effectively done is taken a Spring Boot camel archetype, which is just a really easy open source project to start with that has a decent amount of Spring-based dependencies just from the straight archetype, and then added some added caching instructions to it. I'll show you what those instructions are in a slide, but effectively it's just adding the Gradle Enterprise Maven extension to the build itself, and then adding, in our case, authentication information up to our Gradle Enterprise server. But what I'm going to do first is make sure that we're running totally clean. I'm going to remove any local cache data that I might have. Oh, good. I don't actually have any. It's already clean. And bear with me just a second. I'm going to check out our Gradle Enterprise server and just make sure that the cache there is clean as well, because I want to show you a fully uncached build first. Great. So we're just going to make sure that that's clean. And this build doesn't take a whole lot of time, which is ideal for a demo. But we're going to do a clean verify on this project. Great, we're running our tests. All right, so we ran our build. It took about 21 seconds. We did run a build scan here. We can just verify really quick in our performance tab. Make that a little bit bigger for you too. And we can see that, build cache, we got 0 hits. Right, everything missed, but we did store into the local cache, and we stored into the remote cache. Great. Okay, so let's run this build again and see how much better we can do caching a few steps here. And we haven't changed any code, and obviously, if this was a very modular project, you could do even better here, but we took us down to 2.83 seconds because, again, we were allowed to pull a lot of these tasks from these goals, from cache. We go to look at this scan and we go to look at performance. We can see here that we hit the cache 3 times locally, and when we take a look at our total avoidance savings from cache, we see that our tool estimated that we saved about 12 seconds, or 88.7% of our overall build time. Okay, so just imagine this for something that's larger with more modules and more tests, right? Last thing I want to show you really quick. Let's remove my local cache entries. It's not -rf until we've got the right directory in there. How about that? Great. So there's our local build cache. And now we're going to remove that. But when we run Maven clean verify again, look at this. We still pulled from cache because we pulled from our remote cache instead. Right. So, we can verify here that we were able to pull tasks directly from cache instead. And if we look at our execution, we saved, 11.7 seconds, or 83%. Of course, there's a little bit of a network hit involved here. 83% savings, right, coming from remote. And then finally, I just want to show that this does carry over to CI as well. All I've done is taken the same project, checked it into GitHub, and created a Jenkins project for it. So if we look at our workspace, this is just the same project. We've got the extension added and the Gradle Enterprise set up in here. When we trigger our build, there we go. Don't scare me, Jenkins. We can see it run. Now, this isn't benefiting from any cache because we removed our local cache, and this isn't hooked up to the same remote cache. This is using my laptop as its remote cache node. So you can see it's still doing its thing. Okay, so let's just, first of all, this is kind of nice. The Gradle Jenkins plugin, if you haven't seen it in a little bit, has been updated to detect build scans. So if we go back, we can actually pull up this build, and it's nice. It pulls the build scan right out. It's able to detect that, and we can open it right through Jenkins, which is very handy. And we can look in performance, and we can see, okay, we didn't pull anything from the cache on this first one, right? But we did store. We did store remotely, and we stored locally. Great, all right, just like before. So let's trigger this build again. Okay, and we can already see that, 3 of these pulled from cache. We ended up with a much, much faster build. We can look at our build scan here. Look at our performance, and we can say, why we were able to pull stuff from cache. So they're really just to illustrate that every benefit that we're talking about here from caching locally extends out to CI as well. Okay, great. And then if you're a little paranoid too, let's go into the code itself. Let's change something here. Let's save it, and let's run our build again. And you see it's rerunning the tests, right? It noticed that we changed some code, so it did have to recompile a class, which did change the inputs, which means that it couldn't rely on the outputs. But notice it still was able to pull one thing from cache, and you probably already think of what that is. But that is the excuse me. It's effectively, it's the here it is, the test compile. So compiling the test harness itself, right? So the test harness didn't change, right? The code did, but not the test harness. So it was able to still pull that bit from cache as well. So even when code changes, there's still opportunities for improvements. So we don't have time to go deeply into test distribution, but this is the other principle that we're talking about beyond caching, to really act as an accelerating technology for your build. There is, though, a really good video that was put on by Hans Doctor, our CEO and the inventor of Gradle. You can scan the QR code here or pull it up on our tv.gradle.com site if you'd like. And this really goes into how the Apache Cassandra project uses test distribution to speed up their test cycles and the speed at which they get feedback back from their builds. Really well put together video that talks just about how it works, how it works with Kubernetes to do elastic auto scale and all that stuff. So very, very interesting video to look at. So the next part of it, speeding up, is just one part of it. We're talking about making sure that we can speed up our build, but also that over time, as our code base improves and as our project improves, we stay on top of our speed and we don't introduce new regressions. So ultimately, we all know this, and what gets measured gets improved, right? Attribution here is debated. It could be a lot of different people. Build scans provide a comprehensive, shareable summary on the performance dependencies, failures, test executions, and more. All right, we've looked into these a little bit already. It's easy to spot bugs and failures, and again, completely self-service to the developer, right? So even in the CI chain, you saw how cool that was, that in Jenkins, I could just open up the build and click right on a build scan. That's a self-service way for developers to start diagnosing problems with the build that happened in CI, where they might normally have to rely on a build engineer to do that. So yet another area where we kind of eliminate a bottleneck, eliminate some friction from the process. To set up a build scan, you already watched me do it in the demo, but here's kind of everything in front of you. If you're a Maven user, just add the most recent Gradle Enterprise Maven extension. You're not signing up for Gradle Enterprise when you do this. This is a freely redistributable plugin that's sitting in, I believe, Maven Central. You're just going to be pulling it straight from there. If you need to capture the jar and put it in Sonatype or whatever, you're completely allowed to do that. That's fine. And then you'll configure your Gradle Enterprise configuration in .maven to just have a blank one, right? This is kind of like the freemium version of the scan. If you do have a Gradle Enterprise server, if you're already a Gradle Enterprise subscriber, then you can pop in the URL for that server here in this block, and it'll hook up your Maven scans to your personal Gradle Enterprise server. But if you just leave this as a blank configuration, it'll hit the main scans.gradle.com server that you use for any other build scans. If you want to turn on caching in Gradle, by the way, it's not turned on by default. Very simple. Gradle.properties, update one line org.gradle.caching equals true. And you'll be able to validate in the build scan that caching was actually turned on. From the Gradle CLI, if you're just running Gradle build just from the CLI, excuse me, I'm running Gradle build build cache if you want to turn on caching on the command line, and a -- scan if you want to run the scan from the command line. All right. We're going to do this from scratch. We've already, we focused last time on kind of the cache. We're going to run through from scratch really quick, just adding the build scan stuff to a blank Maven project, just starting from scratch. So let me share my whole desktop again. And we are just going to start here with a brand new project, just so that you can see sort of exactly the methodology here if you want to repeat this. And we want to create a Java project. We're going to create a Maven archetype project here. We're going to look in a remote catalog, and we'll look for Camel Spring. This is our Spring Boot Camel archetype. We'll just do the newest version of it. Let's call it com sf jug. Why not? And we'll call this SF Jug Demo. Oh, Jug Demo, sorry. And we are going to drop this in demos, SF Jug. Great. So we'll give that just a moment for Maven to do its thing and pull out its sub project. We'll just give it all the defaults here and open it up. And great, so this should look familiar. This is the same project that we just had pulled up before. Here's our Spring Boot router, right? But we haven't added any of our Maven configuration to it yet. So the first thing we want to do is create a .maven directory in the project itself. So we're going to create a new folder here and just call it well, we're not going to do it there. We're going to do it here. And we're going to open a terminal here because I don't like the way that it's navigating. Okay. Now, this directory, if you want to make it local to the project, you can just drop .maven right in the project root like we're doing right now. If you want to do this for every Maven project that you run in your environment going forward, you can create this .maven directory in your home directory instead, and it'll be a global configuration for any of the Maven builds that you run going forward. So we need to create two new files in here. We need to create our extensions file first, and we also need to create our Gradle Enterprise file. For our extensions, we're just going to copy and paste that section that I showed you before. Sorry, it's on my PowerPoint. We're going to save. And kind of like we mentioned before, we're going to just do a blank Gradle Enterprise config in here. Since we're, I just kind of want to show you the, what you could do right now, starting from scratch. And let's do a Maven clean verify. And it's going to go through and do its thing. Not pulling from cache. I detached it from the enterprise server. It's going to prompt you just like in a Gradle scan to do the terms of service. There's ways to configure around that. Let me know if you're interested in that. And then from there, that's it. We've got our build scan for Maven. All right. By the way, well, we didn't actually have to pull any dependencies here. This dependency resolution tab is what I mentioned before that will show you how much time was actually spent downloading dependencies for the build. So this question was asked earlier, how can we tell, how can we separate or look at the performance that was coming from downloaded dependencies? And you can see all that stuff right here under the dependency resolution part of the performance tab in the scan. All right, we got about 5 minutes left. Let's wrap things up. Okay, so we now know that feedback cycles are really important to keep things fast. Fast feedback cycles are part of making sure that developers can maintain a creative flow. But what about making sure that over time, all of our success and all of the success we have with our great enterprise application doesn't lead to performance regressions, right? Why is data and keeping data essential to keeping our builds fast? Well, because performance regressions are very easily introduced, right? Infrastructure changes, new annotation processors, versions of annotation processors, changes in the build logic configuration itself, code refactoring, even office locations, changing geographically can introduce regressions. So there's still a lot to discuss here. We need to talk about rolling up failure data to make sure that we can determine what of that data might be actionable to improve and eliminate this failure for other developers so that they can avoid the bottleneck entirely. And what about looking at trends and insights? Well, the Developer Productivity Engineering Product Management Office, which we highly recommend, really actually building a dedicated function for this, should centralize these metrics and use it to ensure productivity improvement, just pulling data, basic data about how long builds took and pulling them into some central source. And not just about speed, but also, about things like the failure analytics and trends in the way tests are running. We want to compare test and build runs across multiple runs to ensure that we aren't running into flaky or non-deterministic behavior. If we find this flakiness in the test further left, we can improve the state of that test for all developers so that they're not hit with those same bottlenecks. And we can significantly reduce time spent spent on troubleshooting builds if we're able to look at trends and failures across the whole organization. I would suggest, we don't have time to go into this, but we've already shared this link. Please poke around in Spring's DPE dashboard, take a look at what they've done, pull down their source. If you want to go through some of the experiments that we mentioned before. We do have a book on this subject that's out on our website as well. If you kind of want to be a hero and bring some of these principles into your business, this is a free ebook that's going to teach you kind of more detail about what we discussed today. Dive into, it's a long ebook, dive into a lot of the techniques and patterns that we implement to achieve strong developer productivity engineering in an organization. And just some next steps from today's talk, I would recommend trying a Maven or Gradle build scan. Remember what we did in this talk, or if you're using Gradle, just do a -- scan. Check out the docs.gradle.com, and then read about build scans and build comparisons too, and what that can do as well.